Hi, my name is Daniel Reisen. I'm the EMEA sales manager for the Imaris business. And during this talk, I will present you Imaris, an image software solution for the visualization, analysis, and interpretation of 2D, 3D, and 4D microscope images. During this talk, we will focus on that software to show you that it's an ideal solution for high-resolution image acquired on an Alpha3 light sheet microscope. I will cover the following topics during my talk. I will give you an overview of the Imaris family of software, followed by a workflow for the Alpha3 obtained images into Imaris, how to convert the TIFF-generated files into the IMS multi-resolution file format, stitching these tiles with Imaris Stitcher, render those stitched datasets in Imaris, and then finally I will conclude with some examples of analysis possibilities in Imaris. So the Imaris family of software is composed of Imaris, Imaris Stitcher, File Converter, and Imaris Viewer. Imaris is the flagship of 3D, 4D microscopic image visualization, analysis, and interpretation software. It allows you a variety of application-based modules. It's high performance and easy to use. It's big data capable with dynamic multi-resolution rendering and both Windows and Mac OS compatible. Imaris Stitcher is mainly used for 3D, 4D image tile alignment and fusion. It's also high performance and easy to use, big data capable. Imaris File Converter is a free tool for converting whatever microscope files into the Imaris file format. And Imaris Viewer is a completely free tool to view raw microscopy images, but as well view image files with some objects. And this can be downloaded from our website. Imaris contains a full workflow. It embeds an image browser to select actually an image you want to visualize. And on this image, you can apply some detection and analysis methods. These methods can be saved, stored, and applied in a batch manner as well. We provide a tool to give some interpretation of the data and, of course, some output options like snapshots and videos for the presentation. Imaris is composed of several modules listed here on the left-hand side, and we provide as well several packages depending on everybody's needs. Now let's focus on the workflow for the Alpha3 obtained images into Imaris. So the images which you generate on the Alpha3 light sheet microscope will come as TIFFs. These TIFF should be converted first into IMS files using the file converter. Then these IMS files can be opened in Stitcher for fusing to obtain a single 3D stack. And then we can go into Imaris to render the stitched dataset, inspect the image with slicers, and eventually create a model, example a surface, create snapshots and movies, and perform various image analysis and segmentation. You also could eventually open that image just in Viewer to render it and create a snapshot. So now I will explain you how to convert the TIFF-generated files into IMS multi-resolution files. Before that, I want just to explain a bit the technology which is behind for a fast visualization of a terabyte of data. Well, the Imaris file format is very efficient with big 3D and 4D dataset. The Imaris file format stores a multi-resolution image pyramid in 3D blockwise layout using HDF5 file format. So on the right-hand side, you see a video where you see actually the blocks in force coloring. Once we zoom in, the blocks get smaller. That means higher resolution. If you zoom out, the blocks get larger, so lower resolution. So we do actually a very smooth handling of these big data sets into the graphical memory and into the RAM of the computer. So let's come now to the workflow, how to convert the TIFF files into an Imaris file. So I have some images obtained from the light sheet microscope. These are mouse brain samples. I will go to Add Files and select the first TIFF file from this series. It will show up here as an input and an output in IMS. However, since it's a series of files, I would need to hit Settings to give some information to Imaris what output sections we want to have. So first of all, we need to adjust the voxel size, X, Y, and eventually Z, because they are not contained in the TIFF files. Further, we need to adjust the tiles for X and Y. And for that, we choose F split. And here on the right-hand side, you see that we have over 500,000 files, but only at the beginning, about 9,000 were selected. So by using actually the F split, we can say that I want individual files for X and Y. And as such, we will have all our files to be used. So there will be 2 channels and 56 files as an output. Here is the result after conversion. On the left-hand side on the disk, so we do some compression of the files, but the files themselves are all of the same size. As you can see, they are all 73 gigabyte of size. And if we go here, for instance, on this image here, as you can see, if you move over with the mouse, it has 2 channels, 73 gig of size, and the voxel size 0.65 times 0.65 times 1 micron. So the next step would be stitching these tiles within Imaris Stitcher. In Imaris Stitcher, you click on Add Files and select all these 56 files. They will be stacked one on each other. And first you would change the color, channel color. I put already the first color in green. Then you might reset the auto adjustment. And you would apply here the grid position. In the grid position layout, you select the number of tiles in X and Y. So we had 7 and 8. So 7 in X and 8 in Y. And Imaris directly applies the layout. By default, there is an overlap of 10%. In this case, we were about 20%. So you change that actually to 20%. And Imaris adjusts that immediately in the visual part. The next step would be now to hit Align All Images, and the process to align all these images will be started. This is the result after the process for the stitching. As you can see, the result is really good in terms of stitching. So one can inspect, of course, in the slice mode as well. So here I have 3 snapshots from lower sections up to more of a middle section to see actually the alignment. So once this is done, we can save the data set as a whole 3D stack. Now this stack we will obviously render now in Imaris. So here is an example of the same data set in Imaris in different modes: blend, normal shading, and mid mode. So what we see at the moment is the red channel in maximum intensity projection, and also now the green in maximum intensity projection. And here we see actually the blending mode with the two channels, and in normal shading also with the two channels. We can also apply some auto slicers where you can inspect the different sections of your data set very nicely. So I will play this movie so that you can get a bit of an impression of what is possible on this data set in Imaris. Now this was only the visualization part. Now I give you some examples for an analysis possibility in Imaris. These are examples not on this data set, but just examples which could be done on this image. So on the top left is surface rendering, where we apply actually a surface model based on intensity levels, and you can then of course render this very nicely with a texture. You can also count objects, for instance, with spots. So you get actually displayed spots. You can color code those, classify these, and get statistical output. If you have, for instance, filament structures like neurons, you could use the filament tracer to trace those neurons as well in your data set and get outputs of length of a filament, branching, and so on and so forth. So I hope you enjoyed this short video on Imaris and how actually you can use the images from the light sheet Alpha3 in Imaris and do some very nice rendering. If you have more questions or want to have more information, please don't hesitate to go on our website imaris.inst.com. Thank you.